Global warming, also known as climate change, is one of the most significant threats facing our planet today. The burning of fossil fuels, deforestation, and other human activities have released large amounts of carbon dioxide and other greenhouse gases into the atmosphere, leading to a rise in global temperatures, changes in weather patterns, and other severe environmental impacts. This might not seem like a significant increase, but it has had devastating consequences. Heatwaves, droughts, and wildfires have become more frequent and intense, causing billions of dollars in damage and claiming countless lives. Rising sea levels and stronger storms have also led to coastal flooding, erosion, and damage to infrastructure. What are the main causes of global warming? The primary cause of global warming is too much carbon dioxide. Global warming is primarily caused by emissions of too much carbon dioxide and other heat-trapping gases into the atmosphere when we burn fossil fuels to generate electricity, drive our cars, and power our lives. These heat-trapping gases spread worldwide and remain in the atmosphere for decades to centuries. Thus, as we continue to emit these gases, their atmospheric concentrations build up over time. Do hydrofluorocarbons cause ozone depletion? A class of widely used chemical coolants known as hydrofluorocarbons contributes to ozone depletion by a small but measurable amount, countering a decades-old assumption. According to a new NASA study, the ozone layer comprises a belt of ozone molecules located primarily in the lower stratosphere. It is responsible for absorbing most of the sun's harmful ultraviolet radiation before it reaches Earth's surface. What would have happened to the ozone layer if chlorofluorocarbons had not been regulated? The visualizations present two cases: the world-avoided case, where the rate of chlorofluorocarbons emission into the atmosphere is assumed to be that of the period before regulation, and the projected case, which assumes the current rate of emission, post-regulation. Both cases extrapolate to the year 2065. Led by NASA Goddard scientist Paul Newman, a team of atmospheric chemists simulated what might have been if chlorofluorocarbons and similar ozone-depleting chemicals were not banned through the Montreal Protocol. The comprehensive model, including atmospheric chemical effects, wind changes, and solar radiation changes, simulated what would happen to global concentrations of stratospheric ozone if CFCs were continually added to the atmosphere. Do methane emissions from wetlands increase with temperature? Methane is a naturally occurring gas, a product of a variety of biological processes. In the case of garbage disposal, methane enters the atmosphere as a byproduct of decomposition. As anaerobic bacteria break down polymers and other carbon-based garbage, like the banana peel shown here, methane gets produced as a waste gas. This animation shows estimates of wetland methane emissions produced by the Lund-Potsdam Genodynamic Global Vegetation Model Wallenschnee und Landschaft version. It is a prognostic model, meaning that it can be used to simulate future changes in wetland emissions and independently verified with remote sensing data products. The model includes a complex, topography-dependent model of near-surface hydrology, and a permafrost and dynamic snow model, allowing it to produce realistic distributions of inundated area. Highlighted areas show concentrated methane sources from tropical and high-latitude ecosystems. The LPJWSL model is regularly used in conjunction with NASA's GEOS model to simulate the impact of wetlands and other methane sources on atmospheric methane concentrations, compare against satellite and airborne data, and to improve understanding and prediction of wetland emissions. Understanding methane emissions from natural sources like wetlands is critically important to scientists and policymakers who are working to ensure that changes in natural systems don't counteract progress in combating climate change made by reducing emissions from human activities.
Flooded soils are deprived of oxygen. Instead produce methane. NASA uses remote sensing to monitor methane emissions from wetlands. Instruments like HUMAIN aboard the International Space Station, airplane monitoring instruments like ARCS and Genie, and satellites like INSAT and Europe Signal 5. Locating and measuring the sources of atmospheric
A warming climate will create challenges for agricultural workers as well as the crops which they grow. This visualization shows the increased number of days per year that are expected to have a NOAA heat index greater than 103 degrees Fahrenheit, a threshold that NOAA labels dangerous given that people struggle to regulate their body temperatures at this level of heat and humidity. These results are from an ensemble of 22 global climate models from the 6th Coupled Model Intercomparison Project bias adjusted by the NASA Earth Exchange. Two projections are visualized, one for a moderate emissions climate scenario and one for a high emissions climate scenario. In 2023, Arctic sea ice likely reached its maximum extent for the year, at 14.62 million square kilometers. Continuing the planet's long-term warming trend, global temperatures in 2021 were 1.5 degrees Fahrenheit above the average for NASA's baseline period, according to scientists at NASA's Goddard Institute for Space Studies in New York. NASA uses the period from 1951 to 1980 as a baseline to see how global temperature changes over time. Collectively, the past 8 years are the warmest years since modern record-keeping began in 1880. Global mean sea level is an important climate indicator, providing information on how the ocean is warming and how much land ice is melting. Global sea levels have been rising for decades in response to a warming climate. The annual rate of rise, or how quickly sea level rise is happening, has also increased from 0.08 inches per year in 1993 to the current yearly rate of 0.17 inches per year. This visualization shows extremes of the water cycle, droughts and pluvials, over a 20-year period, 2002 to 2021, based on observations from the GRACE and GRACE-FO satellites. Dry events are shown as red spheres and wet events as blue spheres, with earlier years being shown as lighter shades and later years as darker shades. The volume of the sphere is proportional to the intensity of the event, a quantity measured in cubic kilometer months. In conclusion, the lost decade in the fight against global warming is a wake-up call for us all. We cannot afford to continue business as usual and must take urgent action to address the problem before it is too late. By working together, we can reduce the impacts of global warming, protect our planet, and create a more sustainable future for ourselves and future generations.